Mr. Manley. In this video, we're going to be talking about angles on a unit circle that are not at one of our convenient angle multiples. So by convenient angle multiples, I mean pi over 2, pi over 3, pi over 4, and pi over 6. And these multiples are convenient because we have predetermined, or we have already calculated what are the coordinates, what are the x and y coordinates that go with those angles and the multiples of those angles. In this case, we're going to talk about an angle that is not one of these convenient ones where we know the xy coordinates, but we are given the xy coordinates. So think about this, what this point here means. This point that is at 12 over 37 for the x coordinate and negative 35 over 37 for the y coordinate. Let's just look at that on this circle over here to the left. If I go over 12/37, just approximately, right? That's like a third of the length, right? It's almost 1/3 of 1. 12 over 37 is really close to 12 over 36, which would be exactly 1/3. And then I've got the y coordinate is really close to 1, really close to -1, negative 35 over negative 37. So if I go down here, there's the point. The point that this is referring to is somewhere in here, somewhere around here. And there is an angle that is associated with that point. So if I took an angle and I rotated around, and ended up there, these would be the xy coordinates of that point. Now, the nice thing about this is that I don't need to know anything about the angle, or I don't need to know anything about the angle measure. I do know something about the angle, right? I know what its xy coordinates are, where it intersects, where the terminal side intersects the unit circle. So with this information, I can evaluate any trig function value for that angle, even though I don't know what the angle measure is. So for instance, tangent theta, where theta is this. Again, look over to the right. So this is theta. That rotation there, whatever that angle there is. I mean, what can I say? I can say it's more than 270 degrees. Maybe it's about 280 degrees. And I'm going to call that angle theta. Well, what is the tangent of theta? The tangent of theta for any angle on the xy axis, where we draw a circle around the xy axis, is equal to y over x. Well, I've got the y and the x over here. The y is negative 35 over 37 over the x is 12 over 37. And hopefully your arithmetic is good enough that you could simplify that to negative 35 over 12. And that's the tangent of our angle, negative 35 over 12. Let's look at another one. Say I want to know what's the sine of angle theta. Again, remember, angle theta is this angle that we've drawn over here that has an x coordinate of 12 over 37 and a y coordinate of negative 35 over 37. Sine is y over r. Well, I know y is negative 35 over 37, and r, well, it's a unit circle, right? What's the radius of a unit circle? It's always 1. So that's negative 35 over 37 over 1. We don't really need to write that over 1 part, right? But just for instructional purposes, I've shown it. And yes, the sine of theta is negative 35 over 37. Let's just look at the last one. The cosecant of theta. Now I could say that the cosecant of theta is r over y, and I would be correct. And I could use an r of 1, and I could use a y of negative 35 over 7, if you follow me. But how about this? Sine of theta and cosecant of theta are reciprocal of each other. So if I know what the sine of theta is, which I do, the sine of theta is negative 35 over 37, and I know that the cosecant is the reciprocal of sine, can't I just say that cosecant theta is equal to negative 37 over 35, which is the reciprocal of sine? And I don't have to talk about r or y at all. So this is a particular type of problem where we're given the x and y coordinate of an angle without knowing anything about the measure of that angle. And if we have the x and y coordinate, and we know that it's a unit circle where r equals 1, it's very easy to determine the trigonometric values of that angle for sine, cosine, tangent, and the others.